So next, we have about 1 hour, and I plan to go through at least one examples from Google. It's about navigation. There is a cupcake example, and one more. It is like something like ordering, restaurant order example. So first, let's clone Cupcake. I will move it to the top because it's kind of fast, and see what it does. Example is not really smart, but it has 3 screens, and at the last screen, it opens another app. So let's concentrate on navigation stuff. Okay. First, let's clone it and see what it does. So code, copy, and this is from Google directly. I didn't create a copy of it. It is directly from Google. Are you with me? Please clone it, okay? It's not total garbage, it is somewhat useful. Let's stop it, and file. I will close this one, bad data. File, get new, oh no, I can do this here, right? Get from version control system, Command V. Cupcake. What? Is link is on Slate. I created link cupcake example. It takes to some repository from Google. It is this training cupcake. And I clone at this part. Here it is, cupcake. Let's clone it. Trust project. I don't want to mess with libraries because it may take a while. So let's just look what is inside and leave it as it is. Okay. In terms of libraries. So let's wait. It is using Compose, a navigation framework. Okay. Let's don't touch it for now. Okay. Just close it. By the way, let's update Android, but not during break because break is already gone. So let's do it tonight, update it. Or just have another short break just to run update to see. Because it says new Android Studio is up. See? Update and new is Ladybug. Hopefully it's not breaking one. Okay. Okay, so let's run it. I will update it before I go home because connection here is a lot faster than at my home. Here is how it starts. Again, this is imitation of some kind of mail order of cupcakes. And it's not really flexible in terms you can order cupcakes only of one kind. You cannot order one cupcake, which is, I don't know, vanilla, another one is chocolate. No option like this. Only one kind of cupcakes. You have choice 1, 6, or 12. You cannot order 10. So you see, it's kind of dumb. Okay, so let's continue. Okay, 6 cupcakes. After this, you choose kind of cupcakes. And price doesn't matter. So if it is 6, it means $2 each cupcake. You change this and price is still the same. Okay. So I chose chocolate and I click at next and choose pickup date. Okay. Obviously it has several screens already, right? And next, summary, 6 cupcakes, flavored chocolate, pickup date. There is no chance to order different cupcakes. It's only the same kind and only 3, 6, or 12. So it's a, yeah, it's a demo. It's not actual ordering program. But when I click send, it tries to open email program. It says no recommended, not email, it is a kind of program out of choices that can share data, share text. And email is just one of them. So what did they do? It appears like they used implicit intent to open another program. Okay. And I think email is just one of them. Okay. So I cannot open email on the emulator because if I try to do it, it will ask me to sign in some email account. So it is pretty much it. It tries to open some sharing program. Okay. So let's see the code. And again, as you see, this program is not super brilliant, but at least it shows several steps and it shows clue how to open another app. So let's find it. In the data, we have a data source, and in the data source, they just did brute force as before, as in my pet examples, they just hard-coded lists. List of flavors and list of how many? 1, 6, or 12. States. So this is data objects that will be shared between screens. And every screen will add something to this object. So they use view model to share data between screens, similar way how you do it in assignment, and this is how I did it paper rock scissors. Just they have more screens. So this UI state is inside of view model. So order view model, here it is. And UI state, it is mutable state flow. So they use it state flow. Right? And state flow is public, mutable state flow is private. So for data encapsulation, because GUI is supposed to display data but not change it directly. So set quantity is called on the screen when we click this piece, right? So what does it do? This is current state. They copy current state and they will replace quantity with new quantity. By default, it's probably 0, whatever. Okay. And they change price by calling calculate price. That is probably just they receive number of cakes multiplied by 2. So this is it. Where's calculate price? Calculate price. Oh, price is dependent on pickup date, potentially. So it is not just times 2. Okay, continue. Calculate price, and this is a copy, replace to send quantity. Set flavor, it is this screen. So this is called when we select something here, on click. So it is updating, calling update on every click here. Click chocolate, it will set chocolate. How do I know? Let's try. Log D. Remember that we talked about log D. A log D, we need to import this thing in PROG class order view model. And this is reasonably generated smart, right? So call it desired flavor. So let's see how it works. Let's stop it, run it, because it needs to recompile this part. And I click cat, and I will filter this with order view model. Order view model. Okay, this. Nothing so far. Here it is. You see, flavor, set red velvet, salted caramel, coffee. Okay, so potentially very useful, right? So this is how to deal with log D. Okay. And this way you can check which function is called, what parameters use it, and what happened inside by just printing stuff out of those functions. Okay. So this is another example of using logs. Right. So let's see navigation. Navigation in this program is a little, I would say, wordy. I'm not sure the right word. Okay, you will see. Not explicit, I would say. So let's start. In main activity, we eventually call CupcakeApp. So what is CupcakeApp? In my programs, I have a function called app_root_screen. It is my notation. Google don't use this app_root_screen. They use functions that is much similar to the name of the app, which is essentially root screen. CupcakeApp. So let's find it where it is. Cupcake screen. Here it is. No, not this one. Going back. CupcakeApp. Yes, it is in Cupcake screen, KT. So let's go there. Cupcake screen, KT. CupcakeApp. Okay. So they create view models the same way as we did before, right? And as a parameter of CupcakeApp, they created controller the same way, nav controller. Yeah, why not? We can. And next, they said we didn't have it before, this one. And the reason was that we didn't have it because I was replacing entire screen. But what they do not replace entire screen. They replace middle portion only. And just because they replace only middle portion, they have additional issues to solve. Because when they replace middle portion, they have to update this part. When we update content, we also have to update this part. So the logic is not super straightforward when they update this part. So what do they do? They use navigation, they use entry from the navigation stack. And they retrieve it as state, so they make it observable. You see, entry as state. So this is state object that contains navigation backstack entry. Why? Because when we navigate, it should trigger update of this top bar. So you see, top bar is outside of navigation window. But they want to update this top bar when we navigate. So this is the logic what they used. I think this is kind of nuts, but okay, it works. So as you see that this is car fault and this is top bar. Nav host is below. So they don't replace entire piece, they replace center portion. But instead of replacing the entire piece and also use different title when you replace it, they trigger update of the screen using this backstack entry variable. Because when they do so, they need to update table, this title. Okay. Next, in order to update title, they also use name of the destination. Again, why? Okay, it's a choice, or it's a demo that it's possible to do. So this is backstack entry, and this is location on the navigation stack. A destination, I don't know what it means, some object inside of that entry, and route. Route, it's a current location. This or this. Remember that in my case, I use a just string. Just to make it more explicit, I type it the string. What they have here is also string. But this string is hidden inside of these objects. So this is string. If you click on this, you see it is actual string. But this string is not assigned directly here. It is inside of Cupcake screen start and name. Why? There is some reason behind it. One of the reasons that if we define constant, it's harder to mistype it because it's a constant. So when you navigate to this location, you don't type the same constant because you can start screen and in another place you miss letter, so it's not exactly start screen. So it will not work because just mistype it letter. So for this reason, they define it constants here for the location, but it is still string. So Cupcake screen, whenever it is, contains object start and name. This is object. So let's find it. Cupcake screen. I'm not here, I'm in this. So, yeah, Cupcake screen. It is an enumerator that contains object of enumerator type, and this object of the enumerator type contains strings. And these strings are picked from string resource because they displayed here. Somehow they use string from this string resource for navigation address and for displaying this. Why? In my opinion, it's strange, but they do it. It works. So I would say logic is less straightforward, but it is similar. Because they replace this portion, and just because they replace this portion, they have to trigger update of entire screen to replace content of the top bar. In my opinion, it is simply just replace entire screen instead of doing it. And in future examples, they do it actually. I suspect it's only examples, and they do it this strange way. Maybe next following example it is the same, but after this, they will stop doing it because it's obviously more complicated. I definitely not recommend it because less straightforward logic. Just replace entire screen. Unless you have some complicated piece on the top that you don't want to redraw for some reason. It is the only place when they use also enum. Maybe in further example, yes, but later they will stop using enum for the addresses as well. Because it's nuts. They do something else later. They also combine addresses with title, but as separate string. But in this case, it is the same string, which is also okay. It works. All right. So current screen, they pick route. And what is this? Remember what's that? It's Elvis operator. How it works? If it is null, use this one. So if somehow they cannot pick route, they just use default one. Okay. Collected state. So this is navigation host. So they receive a view model as a parameter, and remember that view model contains state flow. And state flow does not trigger screen. In order to trigger screen, we need to convert it into state using collected state function. So this is the reason. So this is container that contains state. But this variable, it is content of the container. Why? Because it's by. We delegated getter to the container. So when we refer to this variable, it's actually calling getter of the container. And from the first screen, the key sends call navigate to flavor screen. This is flavor screen. From flavor screen, they call navigate, they call set flavor and call navigate. They have a function cancel order and navigate to start. It is this one, cancel. So there are two options, either next or cancel and navigate to start. So this is when cancel is clicked, and navigate to next is, yes, on next button click it, navigate control and navigate. Okay. So for next, it is I need to select something, this one, and navigate this. All right. This is pickup date. Where's pickup date? This is pickup. This is also pickup date screen. Also, there is option to cancel and option to navigate to summary. See, nav control, navigate to summary. So navigate to summary. So this is summary screen. And this part is outside of navigation, right? So where it is called, let's find it out. On send button, click it, this one. Share order of this piece. Why do we need context? We need context to create a, what's it called? Intent. Subject, it is what to send, and summary, where to send. So essentially it's sending mail, kind of mail, or some message. Subject, and summary, and context. Share order, it is some function below. Let's find it. Here it is, share order. Here it is, intent. This is what I said. They use intent to open another app. And this is implicit intent, as you see implicit, because we tell the system we want to send a message, but we didn't tell how. Okay? And this is why we saw pop up, how you want to send it. This is what we learned at the previous lesson on slides, implicit and explicit intent. So this is implicit intent. We tell the system, action send, but we don't tell you how. Okay. All right. How apply works? Apply just define this object as this inside of this pattern. Okay. So type, it is actually intent.type, and I assign it. This part is actually intent.put extra and this pair. Okay. What is put extra? You add key value pairs to intent, because intent is key value storage. Key is a string, and value, whatever is matching that. So in this case, it is string. Okay. I'll put extra, and this is summary. And context start activity, and this is intent. So the start activity for the given intent. But they didn't tell what activity, so it is implicit intent. So a system has to resolve which activity of which application to start. I wonder where this context is coming from. From here, okay, and where this is coming from. I don't know. No, we have to look up. Context, it's a base class of many things in the program, including activity. So perhaps somewhere in the code there is a reference to activity that is typecasted to context. So let's find it. Okay, cupcake up. It's probably easier backwards. To find where we call this function, so let's find share order context. Oh, it's coming here. Local context current, this is how it's coming from. Local context is probably imported because we're in composable function. Available because we're in composable function. Local context current. So this is where it's coming from. GUI is, look through GUI. GUI is similar to what we had. This is just stuff displayed vertically, so it's probably just column with some separators. image location. They put images inside of drawables here. So resources, drawables. So this is cupcakes. This is only image. It is most likely it is just one column. You know how to deal with ready buttons already. And as you see, it is, they set clicker on click to entire row. This is what I did in paper, rock, scissors. Because now you can click word vanilla, but it will trigger ready button. So they use a modifier of the row to make it clickable. So this is actually where I learned it, from this part. Okay. I don't think there is anything else is interesting here. It is just quite long. Just play with it, may be useful. Just because it's using navigation and it never pops stuck, each navigation is creating entry in the navigation stack. So this will be going back, going back, going back, and this is kill. It's no, last point did kill. It means when we came to the starting points, now it is killing up. Yeah, good. Previously it didn't do it. Previously, it was just going to previous step. So default behavior changed.